Okay, so for T-mesh network, I'll continue. So what we will discuss is that uh, so first we have the antenna and antenna structure. So for these cases, most of the time we call it driven element. So it can be like a wire that where we our antenna structure is radiated. So for example of a Yagi Uda, so this one is the one that you are connected directly to the source wire, so driven element. So then as you can see here, this driven element, then we want to connect to this cable. So most likely I will try to use an example of the coaxial cable. So coaxial cable, you have inner conductor, we have outer conductor where you have isolator. Okay, so most of the time the cable can impedance we can identify using ZC. Sometimes they use 75 ohm, sometimes they use 50 ohm. Okay, now, if you measure at this impedance, measured at this cable impedance, you try to measure it without having anything structure in between. So from this structure antenna to here, in this impedance the measured over here by looking at this RAM element, so that impedance we call it ZA. It basically means that center point free space input impedance of the antenna without any structure. Okay, then next, if you have two conductor, for example these two conductor, the first conductor the first one is 2a, the diameter, the second one is 2a prime, and S here is the spacing center to center. Okay, and your the radius of this the top one should be bigger than a must be bigger than a prime. So the impedance of characteristic impedance of these two is given by Z0, sin 60 cos minus 1 s squared minus a squared minus a prime squared over 2a prime, or equivalent to 276 log of 10 s over square root of a prime. So I most of the time we use this equation of the Z0. Okay, so and if you have two conductor, two wire with knowing their radius or diameter, with we knowing the spacing and the of this, so we can find their characteristic impedance. Now if you have at this T mesh rod, now this is T mesh rod, take note that T mesh rod, the length must be L prime over 2. In this case, T mesh rod, we use two type of T mesh rod. Okay, so when you have used T mesh rod, this T matching rod will contribute to the ZT, input terminal impedance. So how to find this input terminal is JZ0 tangent K L prime over 2. L prime over 2 is the length, K is the wave number, so our wave number is 2 pi over lambda. So take note that our lambda is depend on the frequency. Okay, and Z0 is coming from this Z0. Okay, so then we can find this ZT. So over here, the problem that I've seen most of the student is when you solve this tangent, take note that our tangent we have 2 pi. If you solve this in degree, your pi should be 180. If you solve this tangent in radian, this pi should be 3.142. Okay. Next one, once you have now you have two conductor. So when two conductor is contribute kepada Z to Z0, then this matching rod contribute pada ZT. So the input impedance that we measured from this segment, this section, we call it Zin. So Zin is equivalent to Rin plus Jxin, basically equivalent to this, 2ZT 1 plus alpha squared plus ZA or 2ZT over plus 1 plus alpha squared ZA. Okay, so meaning that you already have your ZT, you already have Z0, then you have ZA also. Then now the problem is how to find the alpha. Okay, so alpha basically coming from cos minus 1 v and so on, cos minus 1 v squared and so on, and equivalent to ln v over ln v minus ln u. Ln is natural log, so in your calculator you can see this function ln v minus u. So what is a v, what is u? U is a over a prime, as I mentioned previously. A is the radius of the biggest conductor, so most of the time is driven element. A prime is the smallest driven smallest conductor, so most of the time is our matching rod radius. S is again is a center to center. Okay, center to center, and then A prime just now. It's the same. So then you can find your alpha. So then when you replace your alpha, so you can solve this. Then when you solve this, you can have these formations. After that, once you have Z in, so you have R in plus JX in. So we need to cancel this JX in because we want to make sure that our R in or Z in become R in only. Okay, then this value will be equivalent to the characteristic of the cable. Okay, so how to cancel this X in? We will use 2C in, 2 capacitor, right? So these two capacitor, basically how to find that is a 1 over 2 pi f x in. So if you want to find the C in, is a C in equivalent 1 over 2 pi f x in. Well, once you know the frequency, once you know you get your x in, you can find your capacitor needed. Okay, so to summarize this thing, so when you have your C, meaning that you have your Z in over here, then you plus your C in. Now your impedance over here become Z in equivalent to R in only. Now we should make sure that your R in equivalent to the characteristic end of the cable. So then we match this antenna. All right. So that's part 1.